One of the best known examples of a logarithmic scale is the Richter scale, invented in 1935 by Charles F. Richter, the seismologist, studies earthquakes. Anyway, he created it to measure and compare earthquakes of different sizes. Each step on the scale, you can see here, oh, I don't have it here. But anyway, each step on the scale represents a tenfold increase in the amplitude of seismic waves. So it allows scientists to compare minor tremors, ones that we can hardly feel, to massive destructive earthquakes. So anyway, let's journey through the problem that he faced before 1935. Let's take a look at this earthquake intensity graph. You have a minor earthquake that you can hardly feel. This first one, you have a second one that is about 10 on the scale, a third one that's 100, and there's a fourth one that we can't even fit on the page. It is 100,000, so it's just going up by 10 is just not going to work. Okay, well, what can we do here? How can we make the scale more manageable for large differences? Let's imagine then that instead of each tick mark representing 10 more in a linear fashion, then could we make then the second tick mark, so here's the first one is 10, and that's there. Let's make the second one 100, and then make the third one 1,000. So following this idea, then the next tick mark here would be 10,000. This would be 10,000. And then the next tick mark after that would be 100,000. So there's 100,000 here. And then we could fit the third one. The third one as 100 is right here. Oops. That really is a terrible drawing. But anyway, you can see that you have the third one, and the fourth one, which is 100,000, you couldn't fit on this original graph. You actually can fit on this one. And excuse the really bad drawing here, but there's 100,000. Okay, fair enough. Well, instead of just using these tick marks at 10, this first one is 10, 100,000, perhaps we could use, in a way of taking the scale, let's use exponent instead of the actual values. Let's use exponents. So this one would be, this is 10 to the 1. This one would be replaced with 10 squared. This one would be replaced with 10 to the 3. You have 10 to the 4 here, and 4, and then this is 10 to the 5. Wow. So we created this really, these large numbers here, and we can fit it on this graph. Well, let's, instead of using these actual values, let's actually just replace these and say, okay, this is a 1, this is a 2. We're replacing it with just the exponents of 10 here. So this is 3, this is the fourth tick mark, which is 4, and this is 5. So we can erase all these. And then we end up with a graph that looks like, let's bring it down here. We have a graph like this, where instead of it being 10 here, this was, instead of 10 to the 1, this is just the actual exponent, just 1. 10 squared, this 2 represents 100, this 3 represents 1,000. And so you can see that the difference then between, say, 2 points on the scale, this one right here, the actual value would be like 100, and this value here is 10,000. It's actually 100 times 2 points of the scale being 100. All right, well, I hope this can help us understand a little better how the Richter scale works, where it's just 1, 2, 3, 4, 5, 6, 7, 8. But each point on the scale is actually 10 times stronger than the previous tick mark. So we can see then you have this here, which is at a 2, and this one is at a 5. There's only 3 points on the scale, but this red earthquake is actually 1,000 times stronger than this green earthquake. Now we come to the formula for the earthquake intensity using the Richter scale. Now we understand that each tick mark in the scale represents a tenfold increase. And so you can see here's an illustration where you have micro earthquakes here. Richter scale magnitude of 3 is 10 times stronger than 2. A magnitude 4 is 100 times stronger than 2. 5 would be 1,000 times stronger than 2. So each tick mark that you go through in the scale would be a tenfold increase. So you're thinking about the exponents. And here we can understand this, right? When we take a look at log, whenever we see the word log, we really can think about it as the exponent. And you can convert to exponential form, but here it is that the m, which represents the magnitude, is the exponent on 10 of the intensity of this earthquake compared to some standard one. So I would be the intensity of these seismic waves, and IO is this reference intensity. So in this context of the Richter scale, then, if you were measuring two earthquakes, like one compared to another, then you can say, well, then the difference is really, you might have a difference in the scale, but that is those points, like 3 points on the scale, is actually 1,000. It's actually the difference in the points on the scale is the exponent expression on base 10. Remember that each tick point is a 10-fold increase. So one earthquake I2 compared to another earthquake I1 is equal to 10 to the exponent of the differences in their tick marks on the Richter scale. So you can see M2 is the magnitude of the second earthquake, and M1 is the magnitude of the first earthquake. So let's compare this earthquake intensity according to some examples. So I've made up an example. We say we want to find the proportion of intensity for two earthquake magnitudes, say some M2, which is some second earthquake. On the Richter scale, it is powerful at a Richter scale measure of 6.5. And then there's this other one that has a Richter scale measurement of magnitude of 4.5. So how much stronger is this earthquake 2, which had a magnitude of 6.5, compared to an earthquake that had a magnitude of 4.5? Now, according to this formula, I2 divided by I1 is equal to 10 to the difference in the magnitude on the scale. Then we have I2 compared to I1 is equal to 10 to the exponent M2 minus M1. We can substitute 6.5 for M2, there's 6.5, and we can substitute 4.5 in for M1, and we can see the difference on the Richter scale is 2.0, 6.5 minus 4.5. And we can see then that if we raise that number on the exponent of 10, then we have 10 to the exponent 2.0, which is equal to 100. So we can say with some confidence that I2, the intensity associated with the earthquake of magnitude 6.5, is 10 squared, or 100 times greater than the earthquake 1, which the intensity was associated with magnitude 4.5. So you can see the magnitude scale is 6.5 compared to magnitude scale of 4.5. It's 2 points higher, which means that you multiply by 10 twice, right? 10 squared times greater in intensity. Okay, so hopefully that gives you an idea of the Richter scale and how we use it to solve some problems. Good luck, and I will see you in class.